Alright, in this video, we're going to answer a few of these questions, probably just answer 4. Then the rest you can try out. So now, let's answer the first question. So we have f of x to be equal to root of x squared minus 4. And we're told to find the domain of the following function. So when it comes to finding the domain, you have to find all possible values which x can take up for this function to be valid. So now, how are we going to do that? So when you have a radical like this one, what you require is that whatever is inside has to be greater than or equal to what, to 0. So you don't want something that is negative in here, because when you have something negative here, you end up with what? With an imaginary number or a complex number that uh, is what you end up with. And we don't want that, because we are dealing with the real number system. So now we set what is inside to be what? To be greater than or equal to 0. So meaning x squared minus 4 has to be greater than or equal to what? Equal to 0. Then now from here, what you do is you can say x squared is greater than or equal to 4, because the other side, and you introduce the square root on both sides. What you just have is x to be greater than or equal to. So all you have, you have what? Plus minus. No, actually, even from here, uh, what I can say is, you can complete the verses here. Okay, let's draw back a bit. So look at this here. If you do the difference of two squares here, you have x squared minus 4. It's actually the same thing. I just wanted to show you that you can actually do this x squared minus 1, but the approach is the same. And the difference of two squares, you just get x being plus 2, or x minus what? Minus 2 to be greater than or equal to 0. And of course, that just gives you, if you have to take values, not this inequality inequality sign, but if you have to say x squared, I mean x plus 2 and x minus 2 to be equal to 0, then you have that values of x are going to be x to be equal to negative 2 and x to be equal to what? 2. So x will be either negative 2 or what? Or 2. So those are the values you're going to get. But now, why is it essential to have these values? Because we're dealing with an inequality here, meaning we cannot just solve it to say x will be equal to something or that, but we have to get regions to which our values of x will be what? Be valid. So we have to have what? Our critical points. So these here will be what? Will be our critical points. The x negative 2 and x what will be our critical points. Then I can set up what I'm calling my what? My critical table. And that is going to look, so remember how you factorize. This is going to be important. The x plus 2, then x minus 2, like that. This is going to be important. So now what you're going to do is you set up now your table. You see which part of this is going to be what? Be valid. So here I have it like that. There, the first one, I put my equations in there. Then I have this region. So I say this here is my critical value. That's 2. And you have, negative 2, and you have 2. So what is in between here? This is x. If x is in between what? Negative 2 and 2, then this here means that x is what? Is less than negative 2, meaning it goes from negative 2 all the way up to negative infinity. Then this side means x has to be what? Greater than 2 there. So that's how the values are going to be what? To be quoted. But then we have to what? We have to test this. So we have how we factorize. You have the x plus 2, and you have the x minus 2, and you have the overall, which is x plus 2 and the x minus what? 2. So now let's get our values here. So let's pick a number which is less than what? Less than negative 2. So if you pick a value that is less than negative 2, for example, I'm going to choose negative 3. So negative 3, when I place negative 3 where x is, I just get a what? So I get negative 3 plus 2, and that gives me negative 1, which is a negative what? Value. So what I'm interested in is not really the value of the number itself. but I'm interested in what sign am I going to be getting there. So here I'll be getting a negative value, so I place my negative there. Then I do the same for the next one. When I place -3 where x is, so -2, then I'll be having what? I'll be having a negative value. Then for the last one, you're just multiplying, so it's negative by negative, and this gives you a positive. Then now you do the same, you get a number in between this here, -2 and 2. I choose 0, so if I choose 0, I replace there, I'll be getting a positive value because I'll get +2. Put 0 there, I'll get -2, that's a negative value. The positive by negative gives you negative. Pick a number greater than 2, let's say you pick 3. 3 this time, +3. 3 plus 3 gives you what? Positive. 2 plus 3 gives you 5, which is positive. Then you put your 3 where there's x in the other one. That's 3 minus 2. That's gonna give you 1, and that's positive. So positive by positive gives you positive value. So now remember, we said our inequality x plus 2, x minus 2 has to be greater than or equal to what? To 0. So because of the greater than or equal to 0, now you check the regions, which ones would greater than means or equal to 0 means they have to be what? Positive. So meaning your x values will be valid in these regions, and that region where it is positive. And I know that is going from what? This is from -2, like that, all the way up to what? All the way up to negative what? Negative infinity, or from negative infinity up to what? -2. And you can try, let's say -2. If we tried -2 in our equation here, where there's what we put negative, here you put -2. I just get that to be equal to what? To be equal to get that to be equal to 0. So you get that to be equal to 0. So if you put -2 here, so this would be 0. Then you have -2, it will be 0. But this gives you a 0, and we're accepting here since it's greater than or equal to 0, meaning that part for the equal to 0 there is what is accepted. So meaning -2 is not going to be open here. Instead, we're going to close here because that value can be what is valid. So what is now the other point? The other point is, so I say union. Here, if I put 2, replace 2 there, I have 2, 4, there I have 0, 0 multiplied by the 4 gives me 0. So 0 is greater than or equal to 0. So 0 is equal to 0. So meaning it's going to be valid for our inequality. So here 2 all the way up to what? Positive infinity. So these are this is your solution set, which values of x can be taken up. So this, in short, becomes your what? Your domain for the function this f of x, which we have in A. All right. So now let's move on. We look at another one, which is we do B, then we come and do D, then we conclude with E. So our B is f of x equal to x squared plus what? Plus 9. So now notice we want this, since there's a radical, we want this to be greater than or equal to what? To 0. But this, if you were to write it, so if you take this, look, when you take this here, this becomes negative. And if you take the square root on both sides, like, you just end up with plus minus negative root of 9. So now, because there's a negative there, this already tells me I'm going to have a complex number. But now, what am I going to conclude about my domain here? So that complex number, the complex number is not a real number. So now we want x values that are going to be taken up, like that are real numbers. So if the only restricted region is saying that they have to be what? These saying these should be the imaginary numbers, then it means that this here, for real numbers, x squared plus 9, since there's even a squared there, you're having squared, this here is going to be valid for what? For all values of what? Of x, since you have a square there, and you will not have a restriction on the negative part. So this will be valid from negative infinity all the way up to positive infinity. Okay, so even if that was in the denominator, as long as it gives you complex numbers and we're not interested in complex numbers, then that equation has to be valid for what? For all real numbers then. Okay, let's move on to D. And D, we have f of x to be equal to 3 over, we have 3 cubed minus 6x. So now when you're having a function like this, which is a rational function, what you want to avoid is to have a 0 in your denominator. Because when you have a 0 in your denominator, means that function is going to be what? To be undefined. And if it's undefined, meaning it's not defined, of course. So what are we going to do for this one? So what we want is, we're saying the bottom there, our denominator, must not be equal to what? To 0. And what can I do? I can factor out an x here, such that I remain with x squared minus 16. And this here should not be equal to what? To 0. Then I can further factor out this by difference of two squares. You see that you just have x minus 4 and also x plus 4. And we're saying all this should not be equal to 0. So what does this mean for us? This means that x can take up all values apart from what? So x here can equate to what? To that. So meaning x should not be equal to 0. And also, what's the other one? X minus 4 should not equal to 0. And that means that x should not equal to what? To 4. The other one is x plus 4 should not equal to 0. And that just means x should not equal to what? Negative 4. So these are the restrictions that you have in your what? In your domain. So now, if those are your restrictions, how can you write them? You can either write it in St. Peter notation. Just say your domain is just going to be, and that is the set of OX. So set of OX, or you can say X is a member of the real numbers, first of all, such that X should not equal to what? X should not equal to 0, 4, and negative 4. So X should not equal to these values. Somebody can also choose to say X is the domain is just the set of OX such that x is not supposed to be equal to 0, negative 4, and 4, but we're saying x is a number of the real numbers. So you can just write it like this, or you can write it in interval notation, where you're saying it's going to run from negative infinity, I mean, all the way up to what? Negative 4. But negative 4 will not be closed, it will be open there, because it can be equal to what? To negative 4. Then we're saying union, meaning from negative 4 is not part of it, all the way up to what? Up to 0. Then again union 0, again we say it's not part of it because it can't equal to 0. Then all the way up to what? Up to 4. And also then from 4 union going all the way up to what? Positive infinity. So union, that's from 4 going up to positive infinity. So this here, you could choose to write it like this to still be what? Still be correct. So this is what you do when you have such a case. And lastly, we can look at a case where a case like the one where we have what's this here? Question E. Okay, let me erase first. So question E is just saying f of x is equal to root of 2x squared minus 5x minus 7. So the same where it's a radical one, and you demand that this should not, what's inside 2x minus 5x minus 7 has to be greater than or equal to what? To 0. And you can factor this out. So how can we do that? So when we multiply this and that there, we just get that would be, so the product is like negative 40. Then your sum is negative 5, then what are our factors going to what? What are our factors going to be here? So when we multiply, we must get negative 14. When we add, we get 5. So what are my factors? What are my factors? So can I use factorization here to... Can I completely do that? Oh, let me try to work it back. Okay. Plus... Oh, 2, 2, 2, 2, 2. So I have 2 and 14. Oh, why am I... I mean 2 and 7. So you're just going to have... this is going to be... so you want to have... negative 7 and what, and 2, such that when you add these you get negative 5, and when you multiply you just get what, you get positive 7. And this here you can write, then this will be 2x squared, then you have plus this will be what, plus 2x minus 7, x minus 7 greater than or equal to 0, and you have this to be factor out at 2x there, such that you have x plus 1, then here factor out a negative 7, and you have x there plus 1 greater than 0, then you have 2x minus 7, and you have the other one, which is x plus 1. So this is how you're going to factor like that. So now you use that method where we're talking about of you getting critical points. So since we are dealing with an inequality sign there, so your critical points are just equating these your linear factors to 0. So you have 2x minus 7, and this equal to 0, and you just have 2x equal to 7, and you have x equal to 7 over what, over 2. Then the other linear factor is just x plus 1 equal to 0, and you have x equal to negative 1. So those are going to be what, your critical values, your critical points, I mean. So now after getting those critical points, I'm gonna keep this here like that, x plus 1 greater than or equal to 0. Then now we can set our critical table. So a critical table will have a section here where we'll put our linear factors. That's 2x minus 7. Then you have x plus 1. Then you have the 2x minus 7, then x plus 1, like that. So those are going to be your, yeah, these are our linear factors there. Then now you set your, that point, critical point, you have negative 1. Then you have the other one to be 7 over what, over 2. Then you have the, yeah, so now this points is, this means x is what, less than negative 1. X is in between negative 1 and 7 over 2. 7 over 2 is like, what's 7 over 2? 7 over 2 is like 3 point something. Yeah, then you have the other one, means x has to be greater than what, 7 over 2. Okay, so now you want to check the signs. What we're interested in has to be greater than or equal to what, to 0. So now, how are we going to check that one? Okay, so here we can replace, let's replace a value that is less than negative 1. Let's say I get negative 2. So if I get negative 2 in the first one, so I have 2 multiplied by 2, then minus that. This gives me a negative value. Replace negative 2 there, I'll get a what? Negative value as well. Negative by negative gives me a positive. Here I pick a value in between. I'm going to pick 0. 0 there, I put it give me a negative value. Put 0 there, I'll get a positive value. Multiply the 2, I'll get a what? Oh, negative, not positive there. I have to get a negative. Since negative by positive gives me negative. Pick a value greater than 7 over 2. I'm gonna choose 4. So 2 by 4, 2 by 4 gives me 8, 8 minus 1, 7 gives me 1, positive 1, so I get a positive value there. Then there 4 plus 1, 5, then that gives me positive. Positive by positive gives me a positive value, and after getting that positive value, what I'm going to do is from there, what I just do is I check which part is positive. So this one and that part is positive. Then I can test my negative 1. Say, is negative 1 going to be valid here? So if I put negative 1 in this equation here, let's say in this one, our linear factors, so I'll get 2, negative 1 there, negative 7. This here gives me what? Negative 9. Then there, the other one gives me this here and that, negative 1, negative 1 plus, so it will be negative 1 plus 1, which is 0. And this will be 0. 0 is greater, not greater than or equal to, but it is equal to 0. So it will be valid. So meaning to be closed at that point where there is what? Negative 1. So negative 1 here. Then going on the way up to what? Negative infinity. This will be our first interval. Then the other one which we need is here. I can test the 7 over 2, which we already tested, and it will give me 7 over 2 will be part, and it will go the way up to what? Up to positive infinity. So this here is going to be what? Your domain. So this here will be your domain over this function. Okay, so that's how you find the domain of these using also the critical points and when you're dealing with the inequality sign there. All right, thank you very much. See you in the next video.